Hi everyone, welcome back to chemistry. In this video, we're going to continue talking about mass calculations for chemical reactions. So in the last video, we talked about mole-to-mole relationships and how we can use a balanced chemical equation to determine how many moles react with of one thing react with how many moles of another to give how many moles of our product or products. And in this video, we're actually just going to take it one step further and talk about how to go from moles to mass using those chemical reactions. So if you know how many moles you have, you can calculate the mass of either your reactants or your products. Okay, so suppose you're in lab and you measured out some iron in lab, and you wanted to find out, well, how much Fe2O3 can I get out from the amount of iron that I measured out from my chemical reaction? So let's call this substance A, and let's call this substance B. So, and you can do this with any substances or any combination of substances in this balanced equation. So you could start with iron and try to find how much of your product you can make. You can start with oxygen and try to find out how much of your product you can make. You can start with your product and find out how many reactants you would have had before you got to that product, and so on. So you can go whichever way, but as long as you can compare using your chemical reaction the mole-to-mole ratio, right? The ratio that these reactants and products react in, then you can figure out, you can go from something like grams of A to something like grams of B, okay? Or sometimes we even just want to get to moles of B, and you can just stop there, okay? So what does that actually look like? So say we start with substance A, so we measure out in lab, we measure out our grams of substance A, which in this case is iron in this example. Actually, let me just mention that this is an example. So we start out with some number of grams of iron, and we want to get to moles of iron. So why do we want to get to moles of our substance A? Well, the reason that we want to do that is that we want to be able to compare our mole-to-mole ratio or our mole-to-mole factor. We want to be able to say, hey, I know from my balanced equation that 4 moles of iron react with 3 moles of oxygen to produce 2 moles of my product. So I know the relationship or the ratio that those things react in, whereas I don't know how many grams of this I have, right? That's what I'm trying to figure out. So in order to kind of get from quote-unquote A to B, we need to be able to convert to moles first. So how do we convert from grams to moles? Well, we can use our molar mass. So molar mass of what? Of A, yeah. Okay. All right, so now we're in moles of substance A, and we want to get to moles of substance B. Do we have a way to do that? Yeah, we use our mole-to-mole ratio. Mole-to-mole ratio. Okay? Or like they write here, mole-to-mole factor, whatever way you want to think about it. All right. Once you use that mole-to-mole ratio, you're now left with moles of your substance B. And that's going to allow you to use, again, the molar mass, this time of substance B, to get to grams of B. And notice that I've drawn these arrows on both sides. So this goes both ways, right? You can start from B and go to A. You can start from A and go to B. You could have also started, say you knew how many moles of B already. Then you could go to moles of A and then mass of A, right? Okay, so how do we actually do this? Let's do an example. So suppose we want to determine the mass in grams of NH3, ammonia, not ammonium, that can be produced from 32 grams of nitrogen. elemental nitrogen. Yeah, so how would we do that? Okay, let's do this over here. So we have N2 plus 3H2 gives 2NH3. Okay, first step, we need to check that this is balanced. Is it balanced? Yeah, it's balanced. So we have 2 nitrogens on the left, 2 on the right, 6 hydrogens on the left, and 6 on the right. Okay, so this is balanced. Perfect. So we want to know from, what are we given? We're given that we have 32 grams of N2. And we want to get to mass in grams of NH3. 32 grams of N2, and we want to get to mass in grams of NH3. Okay, so right now we have grams of N2. And our goal is to get to grams of NH3. Can we go straight from grams of something to grams of another thing using our balanced equation in one step? No, we can't go straight there, right? We need to convert to moles first. So, but once we convert to moles, right, we can convert back to grams. So let's do this. So we'll go from grams of N2 to moles of N2, and then we'll go moles NH3, and then we'll go grams NH3. So I think that will work. All right, so let's go ahead and do this. So we start with 32 grams of N2. As always, I'm going to put my given conversion factor as kind of the first train track. And then let's see what goes in the next one. All right, what do we know that connects grams of N2 to moles of N2? Yeah, our molar mass. So, now we got to figure out the molar mass. So we'll go green for that one. And we got to know the molar mass of N2. All right, what's the molar mass of N2? Well, we have just nitrogen atoms, right? But we have 2 of them. So what am I going to multiply by 2? Yeah, the atomic mass number for nitrogen. Where am I going to find that? Periodic table. Yeah, so 14.007. And the units are grams per mole. All right, so 2 times 14.007. Let's get that on the calculator here. 2 times 14.007 is 28.014 grams per mole. All right, so that's our molar mass for nitrogen. And we can write this as a conversion factor, either as 28.014 grams per every 1 mole, N2, or we could say 1 mole N2 on top, and then 28.014 grams N2 on the bottom. So which conversion factor do we want to go here? Remember, our goal is to cancel out those grams. So this is the conversion factor we're going to want to use. So let's plug that in. So we got 28.014 grams of N2 per every 1 mole of N2. All right. So let me actually scoot this down a little bit just so we have a little bit more room. Okay, so now we can cancel out those grams of N2, and we're left with moles of N2. So we're in this step now. Okay, now we want to get from moles of N2 to moles of NH3, right? We want to get here. So how are we going to get there? Yeah, we're going to use our mole to mole ratio. Well, what's our mole to mole ratio? How do I figure that out? Yeah, I got to look at my chemical equation. And I have to say, okay, how many moles of N2 do I have to start with? And how many moles of, what am I looking at? NH3 do I get out? Or how many moles of N2 react to produce how many moles of NH3? All right, and then what do we want on the bottom? N2 or NH3? Yeah, N2, because we want to cancel it out. So we have 1 mole of N2 producing 2 moles of NH3. All right, and now we can cancel those moles of N2 out. Moles of N2. And then we're left with moles of NH3, which is exactly where we want it to be, right? For our second step, we want it to be right here in moles of NH3. Okay, so we're not quite done. If you were asked to tell me moles of NH3, you'd be done. But we want grams, so we got one more step. So one more step. We know we're going to have a conversion factor. All right, so how do we get from moles of NH3 to grams of NH3? What connects moles and grams for NH3? Yeah, the molar mass. Actually, let me make this all green. There we go. We'll do our molar masses in green. So let's do our second molar mass. Now we need our molar mass for NH3 because we need something that connects moles of NH3 moles of NH3 to grams of NH3. All right, so almost done, you guys. So we got nitrogen atoms, we got hydrogen atoms. How many nitrogens do we have in NH3? Just 1. How many hydrogens? 3. Okay, nitrogen, I've already found it on the periodic table. It has an atomic mass number of 14.007. And that'll be in units of grams per mole because we're reporting the molar mass. Grams per mole. Hydrogen has an atomic mass number of 1.008. Again, grams per mole. All right, so now we got to kind of do some adding, multiplying and adding. So 1 times 14.007 is just 14.007. And then we're going to add that to 3 times 1.008. And be careful with your parentheses here. If you do this all in one step, you're going to need to put parentheses around this part here, the 3 times 1.008, okay? Otherwise, your calculator is going to think that it's going to get all confused and give you the wrong answer. Okay, so I got 17.031 grams per mole. What am I missing here? Oh, NH3. NH3. I did the same thing over here. Don't be like me. All right. So that's our molar mass for NH3. And now, again, we can make 2 different conversion factors. This time I'm not going to write them out. But just think about it in your head. Which one is going to be on the bottom? Grams of NH3 or moles of NH3? Yeah, moles of NH3 because we want to cancel it out. Yeah, moles NH3. Okay, hold on. That's hard to read. So mole NH3. All right. And then what goes on the top? Yeah, 17.031 grams NH3. Really quick question. Why am I not rounding these numbers for sig figs? Why am I not rounding those? Yes, I'm waiting until the very end of the equation, and then I'll report my final amount of sig figs in my final answer. That just allows us to keep things as accurate as possible. You don't want to round until the last minute, okay? Your final answer needs to reflect the correct amount of sig figs, but your calculations can have more than that, okay? So it's the last step that we want to round in. All right. So let's go ahead and plug all this into a calculator. So we got 32, just looking at the top numbers, times 2 times 17.031 equals that number divided by 28.014. And that gives me about 39 grams of NH3. And I went ahead and rounded to the correct number of sig figs, which is 2. Okay. Oh, that reminds me, we don't count this when we're looking at sig figs. That is considered an exact ratio. Okay, that mole to mole ratio is exact. Okay. All right. Let's see. Just double check. Yeah, we got the correct answer. Awesome. Okay, let's try this learning checkout. Go ahead and pause the video. All right, let's take a look at this. So we start with 45.8 grams of what? Fe2O3. So that's my product. That's this here. So we start with that many grams of my product. And we want to get to grams of oxygen. So this is kind of going the other way. Okay, so we want to get to this stuff in blue. So we're going to say we need to use the molar mass here in that second train track to get from grams of our product to moles of our product. Then we're going to use the mole to mole ratio to get from moles of our product to moles of our reactant that we want to eventually end up with in grams. And then we're going to, again, use the molar mass to, this time for oxygen, to get from moles of oxygen to grams of oxygen. Okay, and that's what our final answer was. That's what we wanted to get to. Okay, grams of oxygen. So like I said, you could be, right now we're comparing these two, but you could also have compared these two, you could compare these two, any of them, right? As long as you know, as long as you have a balanced, keyword balanced, chemical equation, you can find the mole to mole ratio. Okay, and if you know how many grams or moles you start out with, you can get to grams or moles of the other thing. Okay, and sometimes we're already in moles. Sometimes you might be asked just to go from moles to moles, and you can do that as well. Okay. All right, I hope that helps. Let me know if you have any questions, and I will see you in the next video.